Hi and welcome to Unit 1 of this ROS Perception course. In this unit, you're going to essentially create the demo that you saw in the introduction of this perception course. So you're not going to work directly with OpenCV. What you're going to do is work with some programs that generate blob information, and you're going to extract that information and use it to move mirror robots in the way that you want. So you could see this unit as a very slow and an easy way of getting into the perception world. So the first thing that a lot of people have that have problems with in perception is the concept of roll, pitch and yaw. It's because it's very important and it's used a lot with robots that have cameras, and you have to understand it very well. So the roll, pitch and yaw is used a lot in planes. So as you can see in this diagram, when we're talking about roll, means that the airplane turns in this axis. So this is roll. Pitch would be to go up or down in the plane, and yaw axis would be to turn left and right. That's basically what this roll, pitch and yaw are used for. So in case of robotics, but in more precise, in case of mirror robot, the robot that you're going to use here, it's slightly different. So as you can see, you have a roll, a pitch, and a yaw. Here you can see some animations of what's the effect of moving, turning in the roll axis, in the pitch, and the yaw. As you can see, the roll would be to turn, to go up and down the head, more or less, in this axis. The pitch would be to turn in this axis, so here, and you can see the effect. Why do I say this is going up the head, going up and down? It's not exactly true, because if you turn your head, then it won't, if you do the roll, it won't go up and down the head. So you have to have the idea that the roll will make the robot head turn around this axis, the roll axis, and the pitch axis. The yaw, it's a bit more easy to understand because it makes the head turn left and right. So that's easier to understand. Okay? How do you turn the robot? If you go here to the web shell and do a ROS topic list, you see that you have some command topics here. So you can see meta, pitch, joint position command, the roll, joint position command controller, and the yaw. Essentially, if you write on these topics, mirror robot will turn the demanded, the degrees, the radians that you gave there. Okay? This is important that you know when we get to the part that you have to move the robot head. So now that this is clear, to work around the simulation, the only thing that you will need is to move the ball so that you can know if your algorithm is working or not. And also because we need to position the ball in front of meta. So we launch this launch that we used in the introduction, so nothing new here. And we'll move the ball more or less in front. Let's see. Okay. Yeah, more or less. Okay. We close. And then we're going to see what meta camera is seeing. So for that, there are many ways of doing it. You can use RViz and add a camera in the RViz. Sorry. but this way it's much faster. So you're going to use the RBT Image View. That is just to see camera topic information. So we go here, we click on the Open Graphical Interface, and inside here, after a while, you'll get this GUI, which has all the camera information, all the camera topics that are available in this simulation. In this case, you only have one, which is the Meta Camera 1. And we are going to select the image RAW, for example. Then we're going to wait, and there you have it. So yeah, we positioned the ball in the right place. As you can see, it's tilted. Why? You can see here. Okay? That will be fixed when you publish in the roll and pitch command, so don't worry about that. Okay, now we are sure that Meta is seeing the ball. Okay, so we can close it. Now, if we go to the notebook, here you have the exercise that we just did. So we positioned the ball so that you can see it. And now we are going to take the first step for the blob tracking. So the first thing we're going to do is launch this blob tracking start color GUI. So we go here and we launch it. As I said, a lot of this is pre-made, so it's a way of doing it easier. So in this GUI, you have what the camera is seeing, and then you have two spaces here. You have the RGB information and the YUV information. So now you have to click on the object that you want to track. So you keep clicking and you see that it starts to paint this black box around it. So you have to click where the box is not. So we go here a bit more. Let's see here, there, until you see that the box is exactly or more or less around the box, around the object that you want. So we're going to click a bit more. Yeah, more or less, yeah. So you see that we have the black box around the object that you want to track, and then you have this information. So you have the RGB, which is the let's say the color red, more or less, that it's giving based on the points that you selected. So it's more or less coherent because you have red values and then you don't have any red, which is coherent because the ball is practically red. It's all red, just that you have a brighter red here, a darker red here, but it's basically red. And then you have this array. This, what it gives you is the range of values of that color. So it's the range of values that you consider that it's the red ball. So you have the red values, the green values, and the blue values. As you can see, it's not exactly the same, but it's more or less the concept that it has of the red ball. Okay? So what we're going to do is, as you can see here, you have this data, and then you have to write that data in some way. As you can see in the notebook, you have slightly different values. So we have 29 here, and here we have 30. It depends on where you clicked in that moment. So what we're going to do is we're going to open, you can write it down directly, but I'm going to open Gedit, and I'm going to select these values. So copy and paste. And also I'm going to, whoops, I think I got it wrong. Okay, let's do it again. Nope. So this sometimes happens. So we have here, we select the ball until we have a coherent red box, black box, sorry. There we have it. And then we copy this, we open the gedit, and we copy here values. As you can see, it depends on what you selected in that moment. So we have this. This is just because I'm lazy and I don't want to type anything. So we can go to our user, Catkin workspace, source. And inside here, you can save any document that you want. So we're going to put the color tests or values. Yeah. txt. And there we go. Now we can close it. And that's it. So you have the color values here. It's an easy way of not getting mixed with the values, but you can write it directly as you want. So next step, we're going to talk about the files and the launch files that you will need to make this work. So the first thing that you have to do is create a package called My Blob Tracking. In my case, I have it already done. So My Blob Tracking package. And inside it, you can do as you wish. I highly recommend you that you follow more or less the things that I do, so that you concentrate on learning and not in what the name I gave him and what's the difference and so on. But as you wish. So I created this folder that it's called color files, and inside it I put this colors values that we are going to talk right now. But I also created a launch file folder and a script, as you wish. So this color txt, what does it mean? What's the use of it? So this color txt file, what it does is you put here all the colors that you want to track, all the blobs that you want to track. In this case, we have here an example of being able to track many colors. So you have it divided in two parts, colors and thresholds. The colors, the important values are this, which will be the color of the box, the bounding box that you will draw. If you remember in the introduction, it was red. Why? Because here it was this value, which is essentially red. And then, so you have to put the RGB that you want, and then the name of the color of the blob. Then these values, you can leave them as they are, so 0 and 10, they're not important. This is 1. And then you have the thresholds, which is the ID of the color, is the range of RGB colors that you consider that color. For example, in the green, we consider green as something that is in this range. Yeah. So if the range is narrow, you will be able to track more colors, but it will be more sensible to light and so on and changes. If you put only one, it will be much easier. In this case, you only need one, so you put the colors, you put the color of the boundary box, the name, in my case, red ball, and in the thresholds, the value that we got here. I leave the values that I had at that moment, but it's more or less the same, as you can see, which makes sense because it should be more or less the same. Okay, understood? Yeah. So, as you can see, in the notebook you have all the explanations that I gave, even more information. It's just that when I explain something, I may point out something to you and so on that maybe it's useful for you. So, this is the main core, this is the heart. Then you need to launch this MyMeta cmvision TC launch, which essentially what it does is use the cmvision package. So if you click here, you'll get this web page, which is it's a blob tracking package. The thing is what you've seen so far. So you have to go to your launch folder, and there you copy paste the values that you have here, which we are going to comment the most important ones. So the most important ones are the camera values and the colors txt. These are essentially what you need to set here. Why? Because the camera can change, and depending on your robot will change, of course. And the txt, because depending on your package or where you have it or where you want to get it from, you'll have to change it. The other values, you can leave them as they are. You can experiment on changing them, but basically to make it work, you need these values. Okay? In this case, we are using the Meta Camera 1 that we use with the RQT, if you remember. And then here in the argument, color file path, well, we put the package where it is and the path, the relative path. And that's it. Then finally, here you launch the node, the cmvision node, with all the values that are needed. You set them here or you set them through these arguments. Yeah, nothing very fancy. Okay, once you have it, you can launch it. So let's do it. So we go here, we check that we don't have anything running. Okay, we launch it. Okay, nothing happens. Of course nothing happens because you're only doing the blob tracking. You're not moving the robots. So what's the difference? Well, let's have a look. Let's do this a bit bigger. So ROS topic. Let's do list grep blob. And now we have this topic called blobs. So let's have a look. ROS topic information blob. It's type cmvision blobs. So let's have a look. ROS message show cmvision blobs. And you have all these values. So let's do a ROS topic echo to see exactly what type of values you have and so on. So ROS topic echo, let's put -1 and 1 to see only 1, and then blobs. There we go. And there you have it. This is what it's detecting right now, the node that we launched in the web shell 1. So let's let's do it again. There we have it. So we have the header, nothing strange. Then we have the image width and height, which is essential to know where the ball is, where the blob is, because depending on the size of the image, it will change, of course. And then we have all the blobs, which is an array, as you can see here. It's a blob array. and we have all the blobs detected. In this case, it's only one, which makes sense because in the txt file we only have one, so it's able only to detect one blob. It could one type blob. It could, if you spawned two balls in here, then you would see two blobs, of course. Yeah. Oops, sorry about that. Yeah. So here we have the name of the type of the blob, in this case red ball, which is exactly the same one of the txt. Then we have the values, RGB, which he is detecting in this case, and then the area, which is 960, which is the area of the blob. Why do we need that? Well, we don't need it for 2D tracking, but we need it for 3D tracking. It's useful because if you know more or less, if you do a calibration procedure, you can know more or less the distance based on the area of the blob. And therefore, you can know at what distance more or less you have that object. And then you have the X and Y values and left and right, which is complementary actually, because if you have the X and Y, which is the position of the center of the blob, the centroid, let's say, of the blob, which we will talk in the next unit, what is the centroid and so on, but essentially it's the center of the blob. So with these three numbers and the name, you can do a perfect blob tracking. Okay? Another thing, when we launched, you see, it popped up this GUI image, which is the tracking that you saw in the demo. So now you have a tracking. Easy, right? Okay. So, as exercise, you have to make a Python script that retrieves the needed information from the blob topic to be able to filter all the blobs except the red ball blobs. So get the red ball blobs. Then retrieve the position in 2D and publish it into the meta commands velocity, which you will use in the next exercise to move the head of meta. So pause the video now, try this exercise, and when you finish, we'll see, or when you get stuck, we'll see the solution. Okay, so here we give you a solution. It's not the perfect solution, it's not the only solution, but it's the one that we give here because it's simple. So we have two parts. We have this run that we execute, and here you initialize the node, you start a publisher to this meta commands velocity, and you start a subscriber to the blobs. And then what you do is create this callback that processes all this data. So what it does is say, okay, if you have blobs, then we go through all the blobs that you have in the array and see if they have the name red ball, because it's the only one that we need to know if it's there or not. And then you have to decide what to publish. So if the blob is centered, then you say, okay, Mira, you don't have to turn your head, which is, in this case, it's centered. In case that it's to move, so it's positioned to the right, then you have to turn right. And if it's positioned to the left, then you have to turn left. Positioned means that in the image of 400 in width, it's beyond 220, and which would be around here. Yeah, and because if the middle is 200, then it would be around here. So in this case, Mira should start turning the head. Okay, and in case of the left, well, it's around here, 180. Yeah, and this, what it does is, as you can see, once you have it, you have the turn, and then what you do is publish there. So it's changing this value, the global turn value, and this publish updates that value here. So you see that turn, it's updated all the time through this callback. It's not the most elegant way of doing it, but it's just simple to start. Okay, so let's see a demo or something. So if we go here and I do, let's see, ROS City, then I go here, let's do a source just in case. Okay, ROS back profile. Then I do a ROS run, my package, my blob, bloody blah, and as you can see, I have it already here. I have track color and meter move head, which is the next exercise. So I'll do the track color, which is this one. And it does anything, or it does. So we're going to see ROS topic list and get cmd. Sorry, I don't remember the name of the velocity. There we go. So you see that I'm publishing right now the values. So let's see what I'm publishing. So ROS topic echo and this values. So I'm going to see what I'm publishing. You see? So it's because it's around here, it's oscillating between turning and not turning. So yeah, that's it. So this is the way you should do it to be sure that the next step will work. And what's the next step? Well, then the next step is moving the meter's head. So as you can see here, we say that you have to use the meter commands velocity topic that you publish in exercise 2 to move the head of meter. What will you move? You only have to move the yaw, because you have to move in 2D space. Okay? Once you have it, then you have to move the ball to see if it's working. Yeah, so pause the video now, try it, and if you get stuck or you finish, then play the video again. Okay? So there are many ways, as I said, of doing this. In this case, what we did is a class called the meter Blob Tracker, which connects to this commands topics and publishes there. Then it has some systems to be able to move it correctly, and some extra stuff so that you can move it not only the yaw but the pitch and the roll. Then we have some conversions, it's just to make it move more smoothly, and it doesn't have any problems of radians and so on and negative values, but essentially is using this. Okay, so we are launching this meter Blob Tracker class, and then we use this search for blob loop, which is, let's have a look, search for blob loop, and say, okay, it's not doing anything. Of course it's not doing anything because we're using a callback. So if we go here, you see we're using this blob info callback, which is this one. And in here, what we're doing is retrieving the values of the angular value z only, and then we add this turn value, which is this value that we have here, to the actual pose that we have. So if meter is in the, I don't know, in 0 degrees in 0 radians, then, and we have to turn 0.1, then we turn it there and we increment it. This is the way it turns the head. You can do it as you wish. And then, whoops, sorry, I have this. Need to move all joints, and here you can move it. So no problem there. And this, what it does is move all of them. In this case, it puts this one to 0, this one to 0, and this one to the value that you want. But of course you've done something different. Okay, so let's see it working. So we have this tracker already running. So what we're going to do is launch this ROS run my blob tracking, and then meter move head. Okay, so now what we're going to do is, if we go up, we have this to move it around. So let's go here. We lower the speed. Whoop. Okay, it seems it's tracking more or less. So let's have a look. There we go. There we go. So I have to get the turning. Yep. What? There we go. Okay. So there you have the tracking. So let's put this more or less here. Whoop. There we go. Now here. Now I'm going to move the ball around. As you can see, it's adapting the way of moving this. There we go. It's doing the perfect track. What's the problem of this? Well, if you go too fast, it may lose track of the ball, and then it won't know what to do. But basically, it's really robust, because you can move the ball around and it follows the camera. It follows perfectly. Okay, so you did your first blob tracking algorithm. Fantastic. Congratulations. So let's go back. Let's close this. Okay, we have all this. Let's close all the unnecessary stuff. And now you have, so if we go here, you have some extra exercises. Now here you have the exercise, which you'll have to track the ball in 3-dimensional space, which to do that you will need these values in the blobs. You need to track not only X but Y and area, because if you remember, in the track script, in the blob track script, you only used the X value, so you need to use the Y and the area value. The area value, you'll have to make some calibration algorithm first to know more or less at what distance, what area the blob has. And based on that, then you can know the distance, if it's far away, further away, or closer. Okay? Then you have to track that in 3-dimensional space and make meter shake when the blob, the ball, is too far away. Okay? And then third is you have to create a searching pattern so that if meter loses the ball for some reason, it starts searching for it. Okay? Because for now, in the algorithm that you have now, it doesn't search for it. It only tracks the ball if it goes into its vision. Otherwise, it won't track anything. Okay? another question is, okay, how do I move the ball up and down? So let's have a look. So if you press T, as you can see, the ball goes up, and if you press B, it goes down, or G, it stops giving it a force up. And this way you can move the ball in three-dimensional space. Yeah. Understood? Okay, and the final extra exercise is use it in some different way. So use it with other objects. For that, you'll have to spawn different kind of objects. You'll have to spawn, for example, a blue sphere, a yellow cylinder, whatever you want. To know how to do that, if you don't, you have to do the courses in TFs and URDFs, because there we explain in more detail how to spawn an object, a custom object, into the world. That way, here you'll have, for example, let's say a blue sphere and then a yellow cylinder, and you can move them around and see how Meta tracks each one of them. And you should see bounding boxes for each one of these objects. Okay? So that's it. Congratulations. So we finished the first unit of perception, and you know how to track objects using blobs. In the next unit, we are going to talk about more in-depth OpenCV and the ROS bridge, which makes the connection from ROS to OpenCV. So I hope you had fun in this first unit, and see you in the next unit.